Alright, so welcome to another topic in our subject statistics and probability. So on the last video, I mentioned that we will be dealing with a sampling distribution aside from the distributions that we had before, like normal distribution, standard normal distribution, and probability distribution of discrete random variable. So as the name suggests, sampling distribution is a distribution created particularly from the sample. So what does it mean? As of now, we're kind of confused so what a sampling distribution is. Right. So before we proceed, at the end of this lesson, you people should be able to identify sampling distribution of a statistics or the sample mean. Okay, but before we totally proceed with our topic, let's try to look back on some terminologies about uh, terminologies that are connected with probability and statistics. So I want you to answer these following questions. First, what is a permutation? And second, what is a combination? Now pause the video for a minute or two and then try to answer it for you to be able to recall what are the definitions of these terminologies. Okay? So a permutation is a mathematical calculation of the number of ways a particular set can be arranged, where the order of the arrangement matters. So this is the key when we say permutation. The order of the arrangement matters, meaning uh, the arrangement in particular object is very important in terms of permutation. So, while on the other hand, a combination is a mathematical technique that determines the number of possible arrangement in a collection of items or a set of items where the order of the selection does not matter. So this, unlike permutation, in combination, the order of the selection or the arrangement does not matter. Okay? So in combination, you can select the items in any order. So for us to totally understand that, let's have some examples. Okay? Alright, so let's say I have here a set of number. Okay? Let's say the first set I have 1, 2, and 2, 1. Okay? Right? So in combination, these two set of numbers are treated as the same. So meaning 1, 2, and 2, 1 are equivalent. Okay, so unlike in permutation, these two numbers are rather these two set of numbers are considered different. Okay, so here in permutation we have two set of number, while when we talk about combination we only have one set of number, since these two 1, 2, and 2, 1 are considered the same in terms of combination. Okay, that's why in permutation says there the order matters, meaning 1, 2 is different from 2, 1. On the other hand, combination, according to definition, the order does not matter. So 1, 2 is the same as 2, 1. Okay, since the order does not matter. Alright, so a simple question here. Suppose that the population consists of 6 employees in a business the random variable of interest, let's say we represent the variable as x. Say we are interested on the number of years the employees have been with the business. Okay, remember that. So our interest here is the number of years the employees have been with the business, kung gaano na raw katagal nag-work si employee sa isang business. So the values of the variable are as follows. So we have here a table. Alright? So we have here the first employee, Sheila. So Sheila is already a year in the business, while Claudine is already 2 years on the business. On the other hand, Mildred is now on her third year on the business, and so on and so forth until Sophia, who is now on her sixth year on the business. Okay, so this is our interest year in the business. Okay, ito yung gusto nating malaman. So yung discussion ay iikot or magsisirculate lang dito sa year in the business. Now, question: what is a sampling distribution of the sample means for a sample of size 2? No? So, before we can answer this question, we must know what are the steps in constructing a sampling or a sample distribution or a sampling distribution as well. Okay? So, let's identify the steps. First, we must find the number of possible samples that can be drawn from the finite population using a combination formula here. So there's a formula for the combination and for the permutation as well. So for the combination, capital N C small n equals n factorial over capital N minus small n parenthesis factorial n factorial. So what does the capital N and the small n represent? So the capital N represent the total number of population, and the small n represent the desired number of sample space. So in our case, what is the number of population that we have? So ilan daw yung nasa business? Okay, so we have 6. We have Sheila, Claudine, Mildred, Divine, Bridget, and Sophia. While for the small n, the desired number of sample size is, gaano daw kalaki yung sample size natin? Alright, so we want a sample size of 2. Okay, remember that. Capital N is 6, small n is 2. So later on, we'll be plugging those values on this formula. Okay, step 2. Randomly draw all possible samples of size n from a discrete finite population of size n. And lastly, list the observed values of the statistics. Okay, and its corresponding frequency. Okay, so let's get straight to the solution. To generate a sampling distribution of the sample, we need to collect all the possible sample size n without replacement from the population. So therefore, hindi na uulit si value. Okay? Since without replacement. Now, how big is our, or how many possible combinations do we have? So let's try to apply the formula for us to have a guide on how many possible combinations do we have given on the table. So by applying the combination formula, we have this. Take note that capital N is 6 and small n is 2. So this, do not worry about 6C2 here on the leftmost side, since that's just a notation to represent this whole thing. Okay, so 6 factorial over 6 minus 2 parenthesis factorial, 720 over 48 is equal to 50. Meaning there are 15 possible sample size of 2. So meron tayong 15 na pwedeng mailista kapag kinumbine natin sila by 2's. Alright? So now let's try to list down the 15 distinct samples. So I have here on my Excel the original table. Okay, so sir, how do we list down? Okay, so this is how we list down. So the method or the technique is we must pair each value here in the year of business for every value here, no? But not by itself. So we will call that a sample. Okay? Now, what is our first sample? First, sige, pair natin si 1 kay 2. So we have 1, 2. Alright? Next, let us pair 1 into 3. So we have 1, 3. Next, let's pair 1 and 4. So we have 1, 4. Next, let's pair 1 and 5. So we have 1, 5. Let's pair 1 and 6. So we have 1, 6. Okay? Next, let's pair 2 and 3. Oh, question. Should I pair 2 and 1? Ask yourself, should we? Alright, it's no. Okay? Since we are talking about combination, 2, 1 is always the same as 1, 2. Since in combination, the order does not matter. So 2, 1, we already have that here in our sample column, and that is 1, 2. Okay, that's why I did not pair 2 into 1. So let's pair 2 and 3. Next, 2 and 4. Next, 2 and 5. 2 and 6. Right? Next. Okay, so we will not pair 3 into 1 because we already have here 1, 3. As well as 3 into 2 because we already have here 2, 3. Okay? So let's pair 3, 4. 3, 4. I hope guys you recognize the pattern how I pair those values. Okay? So I think this is the easiest way to pair such values. And 3, 6. Next, let's have 4, 5. Let's have 4, 6. And let's have 4, 5, 6. Okay, so according to our combination formula, we must have a 15 distinct values. So let's count on that. 1, 2. Let's see if it is 15. All right, so 15. So meaning we already have enough sample. Okay? So we already have enough sample. So this is the um, sample gathered from this table, right? So this will be used in our sampling distribution, this part. Okay? So that's how you pair the values. Next, so now there are 4 newly hired salesperson at Honda Cars Taguig branch. So the number of motorcycles sold by each newly hired salesperson last month was that's supposed to be was 4, 5, 8, and 9. Now let's complete the needed information in the table below. So we have here observation and the sample. Okay. So how many sample size of 2 are possible? So list down all possible sample size of 2. Alright, so let's try to figure that out. So let's compute, no? Sample size of 2. How many daw? I'm gonna copy the question here so that you will have a reference, and then as well as the formula. So I'm gonna copy the formula and then put it here. This formula will be our reference. Okay, so on our table, I mean on our problem, here, what is the value of capital N here? How many total salesperson do we have that are newly hired? Okay, so we have 4. Huh? 4. So N is 4. How about the small n? What is the size of our sample? Alright, 2. Okay, so let's apply that. 2, let's say 4C2 equals. So let's put a equation and fraction. Alright, so n is 4 factorial over parenthesis 4 minus 2 parenthesis factorial times 2 factorial. Right? So I hope guys you still remember what factorial is. Okay, so 4 factorial is 4 times 3 times 2 times 1. While here, we can, since 4 minus 2 is inside the parenthesis, we can already simplify that, and that's 2 factorial times 2 factorial again. So I'm gonna expand the denominator part, and that is, for the numerator, we'll just simply copy times 2 times 1. While for the denominator, we have 2 times 1 times 2 times 1. So where did we get the 2 times 1? It's from the 2 factorial. While the other 2 times 1 is from the, yes, of course, from the other 2 factorial. Okay? So what's 4 times 3 times 2 times 1? So we have 4 times 3 is 12 times 2, 24 times 1 is still 24. Here, in the denominator, we have 4. Right, 4. So 24 divided 4 is, very good, 6. No? 6. So meaning there are 6 possible combinations for this problem. Alright, so let us list down those combinations. So let's go back to the problem. Sorry guys, I forgot. So we have 4 newly hired. Okay, so 4, 5, 8, and 9. So those are the data. 4, 5, 8, and 9. So these are the sales, no? Motorcycles sold. MC sold. Employee. Let's say we have employee 1, employee 2, and we'll just simply drag it down. Yeah. There. Okay. Alright. So now let's list down the possible samples. According to our formula or to our computation, there must be 6 possible combinations. Alright. So let's pair them. Alright. So let's pair 4 into 5. 4, 5. 4 into 8. 4 into 9. Okay. So again, guys, we will not pair 5 into 4 because we already have 4, 5 here, in which, in the principle of combination, are the same with 5, 4. So 5, 8. 5, 9. And lastly, we have 8, 9. Again, so there must be 6 possible combinations. 1, 2, 3, 4, 5, 6. Okay. So we already have 6. So meaning, these are the sample that we can produce, no, when we want a sample size of 2. Now, of course, we can also do a sample size of 3. Say we change this into, let's say, 3, no? Oh, by the way, we already did the question B. The task for letter B. List down all possible sample size of 2. Okay? So let's say we did that. Say we are concerned with the sample size of 3. So how many sample size of 3 are possible? Okay, so let's recompute. Let's go back with the given here. So let's replace 2 with 3, no? 3. So 4 minus 3 will be 1. Okay? That would be 1 factorial. Alright, so let's try to fix this. So 1 factorial is just simply 1 times 3 factorial is 3 times, 3 times 2 times 1. Okay? So simplifying the numerator, we will still get the same. That's 24. And on the denominator, we will have 1 times 3 times 2 times 1 is, okay, good, 6. 24 divided 6 is, alright, 4. So meaning there are only 4 possible combinations that we can produce, from our problem. Okay, so let's try that. Take note that this is n is 2. Right. Now we will be doing when n is 3. Of course, you can expect that when the sample size is larger, the sample here would be lesser compared to a smaller sample size. Okay, so let's pair 4, 5, and 8. 4, 5, 8. What else? 4, 5, and okay, very good. 9. 4, 5, and 9. What else? 4, 5, 8. 4, 5, 9. How about 4, 8, 9? 4, 8, 9. Do we have 4, 8, 9? Okay, so we don't have 4, 8, 9 yet. So we will list that down. Okay. What else? How about 485? No, right? Since we already have a pair here that represents 485, and that's 458. So the last pair would be, okay, very good, 5, 8, and 9. Okay, again, so there are only 4 possible combinations. So these are 4 possible combinations. Okay, right? So, oh, that's the last time. So for this lesson, I want you to answer the check your understanding. That's, I think, a single problem. And then you are just supposed to list down the possible sample size. I mean, um, sample, compute the number of sample. Okay, and then list down the samples. Right? So that will be all. Thanks.